Hey guys, welcome back to my channel. This is part 2 of my water shedding notes. In this video, I'll be talking about water shedding principles for below ground structures, basements. What I'm about to show you are notes from my 10 hours of study on this topic. I've watched various online courses and I've linked to them below. This is not intended to be a complete summary or replacement for these courses. If you'd like to have a deep dive on this subject, I recommend you take these courses in full. Also, please read the disclaimer in the text below. And with that, let's get started. Basements and podiums are areas that are most likely to have problems with water entry, and there are two approaches to waterproofing basements. First, there is the tank basement. This is a watertight structure that is designed and constructed to avoid taking any groundwater. And then there is the drain basement. This is a structure that is designed to take in some groundwater, but then it is collected, redirected, and drained away. A drain basement follows the principle of water shedding before waterproofing. Water shedding is the process of working with water and gravity to manage water in and around buildings. It is important to first collect, redirect, and drain before relying on waterproofing membranes. Before we begin, we need to understand a little bit about hydrogeology. Hydrogeology is the science dealing with the occurrence and disturbance of underground water. If we look at this section diagram, you will see that the underground water is separated into two zones, the unsaturated zone above and the saturated zone below. The boundary between these zones is called the water table line. The unsaturated zone is often neglected because it is assumed that water table level is only to worry about. And the water table line is not always static. It can also rise and drop a few meters depending on conditions. If a geotechnical engineer defines that there is substantial groundwater present, a hydrogeologist should be engaged. Hydrostatic pressure is the pressure exerted by a fluid at rest due to the force of gravity. Hydrostatic pressure typically increases with depth. Most urban sites will require a pit and pump. A hydrogeologist's impact assessment will be able to determine if there will be minimum harm to adjacent sites for a pit and pump to be allowed. Hydrogeologists use a diagram called a flow net to picture the flow of underground water. This is a graphical tool used by engineers to illustrate the volume and pressure of water below the water table adjacent to the structure. It will show how the flow will change once you introduce piling, diaphragm walls, cut-off walls, and other underground structures. Water can also seep into the basement via other forces such as momentum and capillary suction. There are currently no Australian standards for waterproofing below ground structures. However, there is a British Code of Practice, BS 8102-2022, Protections of Below Ground Structures Against Water Entry. While it is a very comprehensive document, it may be tough to navigate and apply. Hence, in the water shedding online courses that I took, Ross Taylor, industry leading expert, suggests these 3 rules of thumbs. The first rule of thumb is that when you determine the water exposure risk, for all projects, consider the water table line to be effectively at ground level. BS 8102 has 3 water table level classifications: high, low, and variable. Consider the water table risk to always be at variable. Rule of thumb number 2. Consider everything to be grade 3. This means that no water ingress or dampness is acceptable in all ceilings, walls, and floors. Damp car park walls and ramps may be acceptable only if the client approves of it. And rule of thumb number 3 is to use a 3-layer approach. Number 1, use structure as the primary protection layer to keep out the majority of the water. And number 2 is to use drainage and cavities to manage water flow. And number 3, if necessary, use barrier protection such as waterproofing membranes and sealants for an extra layer of protection. So that's the 3 rules of thumb. And to end this video, here are a few more best practice tips to minimize water entry. The capping detail. The location and shape of the pile capping are important factors that can impact whether water can enter the cavity. The floor slab above should overhang the pile cap. This deflects water going through the top of the pile cap. And allow the slab to move separately from the pile cap to avoid cracking. Construction joints. Minimize construction joints and plan the joint placements. Because every construction joint is a potential leak, a drain should be placed along the line of a construction joint to break the continuity of any hydrostatic pressure. Concrete slabs. Prevent cracks in concrete through a good mix, reinforcement, and curing. And if required, use appropriate waterproofing membranes. Work with an engineer to produce a deflection contour plan to help determine where you put your drains. Under the slab. Have a 100mm blinding layer of aggregate under the slab to aid in water management. It helps ensure proper drainage and minimize potential water-related issues. Have integral hobs of at least 200-300mm high. 180 integral floors to concrete slabs. Using topping screed to achieve floors is not ideal. External floor finishes. Use pavers on support pads to redirect water flow and provide protection to the water membrane. And lastly, cavities. Ensure that cavity is always clear and continuous. If the cavity is not continuous and blocked up, water will saturate the block wall and run through it. And one last thing before I proceed. While I think I'm a pretty good architect, I'm not your architect. I can't give you specific advice for your specific situation. Please consult your local architect or consultant to find out what to do. I'm simply sharing what I've learned. Please read the full disclaimer in the text below. And if you'd like a free PDF summary of all my watersheding notes and my sketches, check out the link below, click here to see my next video, and subscribe if you want to see more content like this.